To celebrate the first 10 years of CubeSat missions at the European Space Agency, over 120 companies gathered this week in Leiden, the Netherlands, to explore new business opportunities. And of course, Optica was there to better understand end-user needs from the new space industry. In the world of spacecraft, every gram costs serious money. So if you want the cheapest craft, you've got to build the smallest ship. First launched in 1998, CubeSats have become a key tool for universities and companies conducting small, focused experiments. CubeSats come at a bargain basement price, the smallest being 10 by 10 by 10 centimeters and weighing just over a kilogram. Today, CubeSats have grown up to be 16 times larger than that and have left Earth's orbit to travel into deeper space. As they use more complex onboard sensors, the advantages of faster, lighter photonics technologies are becoming clearer. Launchers like SpaceX and 3D printing of robust space-worthy materials were discussed, plus novel propulsion systems that give more control over the spacecraft, especially at the end of life. We spoke to companies behind 12 CubeSats launched towards the Moon, and the first deep space CubeSat to fly by a near-Earth asteroid in what they call a planetary defense mission. Because you cannot repair things in space, traditional satellites have to use technology with the highest level of reliability if they are to last at least 20 years in the harshest environment, outer space. But for innovation, companies prefer CubeSats as a fast and cheap way to test a device. In fact, swarms of these satellites are being used to commercially track the increasing number of wildfires in real time. So let's cross to my colleague Olga Ras for a summary of what we learned.
From this conference organized in ESA on CubeSats, there are three important takeaways that are worth spreading in the optical and photonics communities. First of all, space is not longer owned by governments. It became an opportunity for the private businesses. Second, the satellites and the images that they are collecting becoming more complicated and thus heavier in terms of the megabytes. It's important to be able to process and transfer these images in the still high quality. There are two ways of doing this. One is to transform from the traditional ways of how the information is transferred now via radio to optical and laser communication. The implementation of optical and laser links between the satellites as well as downlinks to Earth will allow to dramatically increase the speed of the data transfer. The second way of doing this is the implementation of artificial intelligence, where already at the satellite we do pre-process of the data to pick the most important data points and information that is worth transmitting to Earth. Our coverage on this conference will continue, and I will give you individual profiles of some of the companies that we have met. Okay, and now we have to leave because it's time to clean up.